A warm good morning to one and all. Welcome back to our maths class. Last week we discussed exercise 2B up to question number 8. Okay, today we are going to continue our class with the question number 9. Exercise 2B, ninth question is evaluate x raised to 5 plus n into x square whole raised to 3n plus 1 whole divided by x raised to 7n minus 2. Okay, x raised to 5 plus n into x square whole raised to 3n plus 1 whole divided by x raised to 7n minus 2. Look here. First, here x is the base, here also x is the base, and denominator also x is the base. And if the bases are same, we can add the powers. If the bases are same, we can add the powers. And also here power of a power rule, we can apply power of a power. A raised to m the whole raised to n is equal to a raised to m into n. So first we can start from here. Okay, that is x raised to 5 plus n into x square into 3n plus 1 divided by x raised to 7n minus 2. Okay, x raised to 5 plus n into x square into 3n plus 1 equal to x raised to 5 plus n into x raised to 2 into 3. 2 into 3 is 6. So 6n. 6n. 2 into 1, 2. So 6n plus 2 divided by x raised to 7n minus 2. Okay. X raised to 5 plus n into x raised to 6n plus 2 divided by x raised to 7n minus 2. How to get 6n plus 2? Because here power of a power rule. A raised to m the whole raised to n is a raised to m into n. 2 into 3, 6. So 6n. 2 into 1, 2. Okay, that is x raised to 5 plus n into x raised to 6n plus 2. Now look here. Here the same power, same base, x. Here also x. The bases are same. So we can add the powers. That is a raised to m. This is in the form a raised to m into a raised to n, which is equal to a raised to m plus n. A raised to m plus n. Okay. A raised to m into a raised to n, a raised to m plus n. So which is equal to x raised to 5 plus m 5 plus n plus 6n plus 2. 6n plus 2 divided by x raised to 7n minus 2, which is equal to how to write x raised to 5n plus 6n. What is 5? Sorry, not 5. 5 plus n plus 6n plus 2 divided by x raised to 7n minus 2. Okay, x raised to 5 plus n plus 6n plus 2. This is 5 plus n plus 6n plus 2. Clear? Which is equal to, how to write, which is equal to x raised to 5 plus n plus 6n plus 2. 5 plus 2 is 5 is a constant, 2 is constant. 5 plus 2 7. Okay, plus 6n plus n 7n. 6n plus n 7n. Okay, 5 plus 2 is 7. 5 plus 2 is 7. 5 a whole number, 2 is also a constant, that is 5 plus 2 7. N plus 6n, n means 1 9. 1 9 plus 6n 7n. Okay, x 7n plus 7 by x raised to 7n minus 2. Again this is in the form a raised to m by a raised to n. Here power is x, here also power is x. A raised to m by a raised to n, which is in the form a raised to m by a raised to n equal to a raised to m minus n. A raised to m by a raised to n equal to a raised to m minus n form. Okay, a raised to m by a raised to n, a raised to m minus n. So this one can be written as a raised to m by a raised to n is equal to a raised to m minus n equal to x raised to 7 plus 7n minus 7n minus 2. Okay, this is written as x raised to 7 plus 7n. A raised to m minus n, that is 7 plus 7n minus 7n minus 2 equal to x raised to 7. We can eliminate this bracket, 7 plus 7n minus 7n minus 7n. Here minus of minus, you know, minus of minus is plus 2. Okay, minus of minus is plus 2. Okay, x raised to 7 plus x raised to 7n minus 7n plus 2, that is x raised to here's plus 7n and minus 7n get cancelled, you know, positive 7n negative 7n get cancelled, then only 7 plus 2. What is 7 plus 2? X raised to 9. X raised to 9 is the answer. Clear? X raised to 9. Okay. See once again, our question is evaluate x raised to 5 plus n into x square the whole raised to 3n 3n plus 1 divided by x raised to 7n minus 2. First we know that power of a power form. This x raised to 2 whole raised to 3n plus 1, that is a raised to m whole raised to n is a raised to m into n. That is first x raised to 5 plus n into x raised to 2 power of a power here 2 into 3n plus 1. 2 into 3n plus 1 x raised to 2 into 3n plus 1 equal to x raised to 5n into x raised to 2 into 3 6n plus 2. 2 into 1 2. X raised to 5 plus n into x raised to 6n plus 2 divided by x raised to 7n minus 2. Now here x, here x, same base, so we can add the powers. If the bases are same, we can add the powers, that is a raised to m into a raised to n, a raised to m plus n. So this can be written as x raised to 5 plus n plus 6n plus 2. What is 5 plus 2? 5 plus 2 is 7. 7 x raised to 7 plus n plus 6n. 6n plus 1 and 7n, that is x raised to 7 plus x raised to 7n divided by x raised to 7n minus 2. This is again in the form a raised to n by a raised to m. Division, same power division. What to do? Subtract the same base and different powers. We can subtract the powers. A raised to m by a raised to n is a raised to m minus n. A raised to m minus n, that is it is equal to x raised to 7 plus 7n minus 7n minus 2. Now here one bracket is there, remove this bracket, that is 7 plus 7n minus 7n, this minus 7n, okay, negative of negative positive 2 and cancellation, plus 7n minus 7n get cancelled, 7 plus 2 is 9, So the answer is x raised to 9. X raised to 9. Next question. Question number 10. Evaluate a raised to 2n plus 1 into a raised to 2n plus 1 into 2n minus 1 whole divided by a raised to n into 4n minus 1 into a square the whole raised to 2n plus 3. Okay, it's the same step we can follow. Okay, here a raised to 2m plus 1 into 2n minus 1, a raised to m into n form, so we can multiply that one. Okay, m into n form you know, so we can multiply that one, which is equal to a raised to 2n plus 1 into a raised to 2n plus 1 into 2n minus 1. Okay, 2n plus 1 into 2n minus 1 divided by a raised to n into 4n minus 1 into a square whole raised to 2n plus 3. This is in the form. Here a plus b into a minus b form. A plus b into a minus b is a square minus b square. A plus b into a minus b is a square minus b square. So a raised to 2n plus 1 into a raised to 2n into 2n 4n square. Okay, 4n square. 2n into 2n 4n square. Now again 2n into minus 1, 2n into minus 1 is equal to minus 2n, minus 2n. Now 2n into 1 into 2n, 1 into 2n is plus 2n. Now 1 into 1, 1 into minus 1 is minus 1. Okay, divided by a raised to n into 4n, 4n square. A raised to 4n, n into 4n, 4n square minus n into 1, n into a square whole raised to 2n. Power of a power, 2 into 2, 4n. Plus 3 2s are 6. Okay, here power of a power, a raised to m the whole raised to n is a raised to m into n, that is 2 into 2n plus 3. 2 into 2n 4n plus 2 3s are 6. Clear? Okay, any doubt? Next step, which is equal to a raised to 2n plus 1 into a raised to, here 4n square is there, minus 2n plus 2n get cancelled. Minus 2n plus 2n get cancelled. The remaining terms are a raised to 4n square minus 1. A raised to 4n square minus 1 divided by a raised to 4n square minus n, a raised to 4n square minus n into a raised to 4n plus 6 equal to, now here listen, base A, base A, base A, base A. So same base with a different power. What to do? Same base and different power. How to do? We can add the powers, and denominator also same base with a different power. So if the bases are same and different powers are there, then we can add the powers. Okay, we can add the powers. Base is same, you know. So which is equal to a raised to 2n plus 4n, 2n plus 1 plus 4n square minus 1. Numerator 2n plus 1 plus 4n square minus 1 divided by, in denominator, a raised to 4n square minus n plus 4n plus 6. Okay, a raised to 4n square minus n plus 4n plus 6. Clear? A raised to 4n square minus n plus, no need to put a separate bracket and all. Okay, 4n plus 6. Now, see here, numerator a, denominator a. A raised to m by a raised to n form, which is a raised to m by a raised to n form. Numerator same, denominator same base. Both in numerator and denominator same bases are there and different powers. So we can subtract the powers. Why? Because here a raised to m by a raised to n. A raised to m by a raised to n is a raised to m minus n. A raised to m minus n. So which is equal to see here, a raised to 2n. Here cancellation is there, plus 1 minus 1 get cancelled, plus 1 minus 1 get cancelled. It will become 0. Remaining term 2n plus 4n square. And denominator, is there any cancellation? Minus n plus 4n is plus 3n. 4n minus 1n. 4 minus 1 is what? Same term, n. So 4n minus 1n. 4 minus 1, 3n. Okay. So this one you put it in a bracket. Minus 4n square plus 3n plus 6. Okay. A raised to 2n plus 4n square minus 4n square plus 3n plus 6. Okay, now equal to, we can remove the bracket first. A raised to 2n plus 4n square minus this, remove this bracket. Okay, this bracket you remove, 4n square minus 3n minus 6. Okay, a raised to 2n plus 4n square is there. Minus, minus 4n square minus 3n minus 6. How you get minus 3n? Here n, minus n is there, plus 4n. 4 minus 1 is 3, that's why. And if we are removing this bracket, all the terms become negative. Now, see here, 2n is there, plus 4n square minus 4n square get cancelled. Plus 4n square minus 4n square get cancelled. Plus 2n and minus 3n is what? 2 minus 3 is what? 2 minus 3 minus 1. So a raised to minus n minus 6. Answer is a raised to minus n minus 6. See, a raised to minus n minus 6. Power is negative, both the powers are negative, we can take the power outside. Minus sign outside. Minus sign outside, that is n plus 6. A raised to minus n plus 6. How? Because here negative, here also negative. When we take all the negative sign outside, inside is inside becomes positive. If we take a negative sign outside, inside become positive. That is, if we take minus sign outside, then inside n plus 6. A raised to minus m. What is a raised to minus m? A raised to minus m or a raised to minus n. What is a raised to minus m? 1 by a raised to m. See, a negative power is here. So how to become a negative power into positive? By taking the reciprocal. By taking the reciprocal. So which is equal to 1 by a raised to 1 by a raised to n plus 6. This is the answer. 1 by a raised to n plus 6. Okay? Clear? Okay. Question number 11. Prove that m plus n the whole raised to minus 1 into m raised to minus 1 plus n raised to minus 1 is equal to mn whole raised to minus 1. Okay, m plus n whole raised to minus 1 into m raised to minus 1 plus n raised to minus 1 is equal to mn the whole raised to minus 1. Minus 1. So here we want to prove LHS equal to RHS. LHS means left hand side. So first take the left hand side. LHS. Left hand side means this one. M plus n whole raised to minus 1 into m raised to minus 1 plus n raised to minus 1. M plus n whole raised to minus 1 into m raised to minus 1 plus n raised to minus 1. Okay, which is equal to, here power minus 1 is both for m and n, you know. Power minus 1, power is a negative, you know. How to eliminate negative power? How to make this negative power into positive? 1 by m plus n. 1 by m plus n whole raised to 1 into m raised to minus 1 plus n raised to minus 1. Okay, m raised to minus 1 plus n raised to minus 1. See here, m raised to minus 1 plus n raised to minus 1. We can't write a m plus n whole raised to minus 1. This wrong. It is wrong. We can't write m plus n the whole raised to minus 1. Because here it is m raised to minus 1 plus not into. If it is into, if it is multiplication, we can give the power separately and we can combine them. We can give separately and also we can combine them. But here plus sign, you know, so we can't combine. That is m plus n whole raised to minus 1. We can't write m plus n whole raised to minus 1. So what to do? 1 by m plus n whole raised to 1 into, see this one, m raised to minus 1 we can make a positive power. How? 1 by m. M raised to minus 1 can be written as 1 by m. And n raised to minus 1, 1 by n. Okay. See, 1 by m plus 1 by n. Now 1 by m plus 1 by n, you know, denominators are different, m and n. So we want to find the LCM. That is 1 by m plus n whole raised to 1 means m plus n, simply m plus n into, what is the LCM? LCM of m and n is here 1 by m plus 1 by n, you know, addition. 1 by m plus 1 by n. Denominators are m and n. So LCM of m and n are mn. M into n. Mn. This is the denominator. Okay, this is the denominator. Then what about the numerator? Numerator we can cross multiply, you know. We know that cross multiply. 1 into n, that is n, plus 1 into m, m. 1 into n plus 1 into m, that is n plus m. Again, which is equal to, we can arrange this. N plus m is same as m plus n, because we already learned addition is commutative. Commutative. M plus n is also equal to n plus m, which is equal to 1 by m plus n into m plus n by mn. Okay, m plus m by mn. Here 1 by m plus n into m plus n by mn. Here denominator m plus n is there into numerator m plus n is there. We can cancel this, you know. We can cancel this m plus n and this m plus n cancel, because here into sign 1 into m plus n is m plus n. 1 into m plus n is m plus n by m plus n into mn. So this m plus n and this m plus n getting cancelled. So the remaining term is 1 into, that is 1, divided by mn. 1 divided by mn. What is 1 divided by mn? Mn, you know, this mn you can move to numerator, that is mn raised to minus 1. Mn means mn raised to 1. Mn means mn raised to 1. 1 by mn raised to 1. This 1 by is there, you know, this mn you want to bring to numerator. What happened then? If mn goes to numerator, mn raised to minus 1 equal to our RHS, right hand side, isn't it? Equal to RHS. Clear? Okay. Next, 12th question. Sub question 1. Prove that x raised to a by x raised to b the whole raised to 1 by ab into x raised to b by x raised to c the whole raised to 1 by bc into x raised to c by x raised to a the whole raised to 1 by ca is equal to 1. So here also the same way, prove that, you know. So LHS, left hand side, LHS is equal to x raised to a by x raised to b whole raised to 1 by ab into x raised to b by x raised to c the whole raised to 1 by bc into x raised to c by x raised to a the whole raised to 1 by ca. Okay, equal to, see here, x raised to a by x raised to b. We can give x raised to a, for x, this x raised to a the power is 1 by ab, and for this x raised to b the power is 1 by ab. For both x raised to a by x raised to b the whole power is 1 by ab. So this is division, you know. We can give this 1 by ab separately. The power 1 by ab we can give separately for both x raised to a and x raised to b. Okay, that is x raised to a whole raised to 1 by ab divided by x raised to b whole raised to 1 by ab into, next, x raised to b whole raised to 1 by bc by x raised to c raised to 1 by bc into x raised to c whole raised to 1 by ca by x raised to a whole raised to 1 by ca. Okay, 1 by ca. Here power is in numerator and this one is denominator, you know. We can cancel. Some terms we can cancel. A get cancelled. Here B get cancelled. Same way B C. Here C A. This is a numerator and this is a denominator, you know. Power. That's why. Now equal to the remaining terms. X raised to a cancelled. Now x raised to 1 by b only. Here x raised to 1 by b only by. In denominator b get cancelled. X raised to 1 by a only. Into here second term x raised to b get cancelled. So 1 by c. And denominator x raised to 1 by b into x raised to c get cancelled. So 1 by a by x raised to 1 by c. Okay. Now here x raised to 1 by b is there. This is here already into sign, you know. Into. Here x raised to 1 by b. Here x raised to 1 by b. These two terms get cancelled. X raised to 1 by a here also x raised to 1 by a getting cancelled. X raised to 1 by c. X raised to 1 by c getting cancelled. So equal to the remaining term 1. This and this getting cancelled. The answer 1. 1 into 1 into 1. What is 1 into 1 into 1? 1. Okay. 1 equal to RHS. Okay, any doubt? If you want, you can arrange this, you know. X raised to 1 by b. And this x raised to 1 by b also you can write here. In this side, okay. Otherwise, no problem. Okay. Answer is 1. Clear.